Welcome back. By now, we know how to do a significant amount of data analysis. Specifically, we know the mechanics of performing data analysis on arbitrary datasets. The purpose of this video is to develop a strategy for how we can frame this analysis into individual insights and then into a structured storyline that we can finally communicate. This is important because, as we have seen, analysis by itself is fairly mechanical and it generates just facts and figures. More specifically, we are now equipped with the tools required to build dashboards. But remember that dashboards have their own problems. You might remember this slide from one of our previous videos. And we have gone over how dashboards leave some things unclarified. Specifically, what question does the dashboard answer? Is the answer evident from the dashboard? And what action should the user take? If we know how to perform analysis, then we know what to put in a dashboard. But that itself is not enough. The purpose of this video is to come up with a strategy which enables us to bridge that gap, going from having data analytics ready with us to actually answering questions at the level of the business problems. You can look at this problem in a different context as well. As you remember, this is the life of data cycle that we had proposed at the beginning of this course. And we said that we would be focusing on the last two stages here, that is analysis and consumption. By now, we know how to do the third step, analysis. The focus of the upcoming material is on the last part, that is the consumption of analytics. To reiterate, because performing analysis is a very algorithmic, mechanical process, it can be automated, and that's exactly what dashboards do. But because it is often left unsupervised, most dashboards just end up throwing a lot of information on the screen without any real insight or hints as to how to navigate the dashboard, how to drill down on a particular element to go deeper into the analysis, etc. So essentially, the consumer is helpless until they find someone who's capable of reading and navigating a particular dashboard. This entire scenario is what we want to avoid. Specifically, as business analysts, we want to, one, create meaningful insights. We don't want to overwhelm our users with analytical details, but we want to be straightforward with our findings instead. Secondly, we want to present our work effectively. The users should not feel like they are navigating a maze when they are consuming our work. And finally, we want to make our work easy to consume. Users should be able to, at a glance, find enough information which enables them to make a decision. As an example, look at this infographic. This is something we built for one of our clients, a major pharmaceutical company. I'd like you to pause the video right now, look at this in detail for a few minutes, and try to understand what this actually says. I'll explain the answer shortly, but it might be useful to see how much of this you can understand all by yourself just by reading this slide. So here is what this infographic is about. It describes the flow of 2054 service requests that were lodged with this company and how they journeyed through the redressal mechanism of this organization. Each bubble here represents a stage of the flow. So you have a stage where the request is drafted, then it is submitted, then it goes to waiting approval, from which it might be rejected, or it could go to the planning stage. After that, it enters the pending stage. After that, it might go to cancel stage, or it could go to the in progress stage. After that, it goes to completion, and then finally to the closed state. The size of each bubble represents how many services are stuck at that particular stage. So we see that most the three biggest examples we have here is that 31% of service requests are stuck in the in progress phase, 17.6 are waiting approval, and 19.6% have been completed. And finally, the color represents whether the bulk of the requests are likely to proceed or recede. That is, are they more likely to go towards the completion, or are they more likely to go back? A green bubble and a green path, so something like this or something like this, means that requests are more likely to go forward, that is, towards completion. A red bubble or a red path like this one means that requests are likely to go back in the flow. And it is here that we see our first big anomaly. Why is the completed bubble red? Actually, if a request is completed, it should go straight away to closed. And the bubble should be green, it should not be red. But it seems like most of the completed requests are going all the way back to the submitted stage. That's really strange. Now, here is the bigger point in this discussion. All of this explanation which I've given you about reading this infographic is very difficult to infer just from reading the chart on your own. And our client probably might have felt the same at some point. There is no way that anyone could have inferred all of these things at a glance by simply looking at this dashboard. Which means that the user has to depend either on us or on some other data analyst to just interpret charts. That's a pure and simple waste of time and money. So leaving things up to interpretation is not always a good idea. Then again, even after I've explained all of this, the user is likely to say that, boss, I already know all of this. I know already that most of my services are stuck at the in progress stage. I know already that most of my requests go from completion to submission. After all, this is my data. What you have to figure out is why is this happening? So then we went into the root cause analysis and we tried to figure out why these anomalies are happening. And as a result of that, we added this executive summary over here, which the user can just read. The chart at this point simply becomes proof of what we are trying to convey. It does not become the central point of focus. One of the most important reasons why this happens is because we tend to focus more on analysis than on insight. So here is the big idea. Analysis is not insights. Analysis is plain bare facts. Yes, some of them may not be apparent and they're definitely important, but at the same time, once they are found, they may have limited value. Insights, on the other hand, are actionable. They empower our users to take action. So generally, what we need to do is apply filters to our analysis. Out of the entire set of analyses that we may have done on a particular data set, we need to figure out which of them actually contribute to insights and which of them are just pure information, which the user may already know in many cases. And that is the problem with dashboards. They tend to give us analysis, not insights. Let's take a moment to think about what we do when we build dashboards. We have some data, we have some analytics on the data. We do a bunch of fairly routine and maybe some domain specific operations on the data. And then something clicks. I get an insight, I get a nugget of wisdom in the data, and then I put a widget in my dashboard, either a chart or a piece of text or some graphics, whatever, which reflects that insight. Now, the problem is that at the initial stage, we have this data set which can be fairly ambiguous. We don't yet know what it means. So we perform some analysis on it, which reduces its complexity a little bit. We get the insight, which by definition is less complex and more meaningful than the raw data. And then in my spreadsheet or my dashboard, I am again increasing its complexity by communicating that insight through a chart. That cannot be avoided, of course, but the fact remains that it is somewhat counterproductive. And we tend to get carried away with this many times. No analyst will ever want to hide their work. We usually go to great lengths to describe in detail what we've done, but not enough attention is given to what we have found. So you see, an Excel spreadsheet is not a dashboard. The spreadsheet is where you do the analysis. It has to be distilled into something the users can consume without going through the same journey that the analyst has themselves. Therefore, a dashboard has to be simpler than the data it explains. It can't just throw data in your face. And it should have just enough flexibility that users can replicate the insights, not the analysis itself. And of course, it has to lean more towards prescriptive rather than descriptive analytics. The user should be able to take away something from the results, which is not simply facts and figures. So this brings us to the question, what separates insights from analysis? To enable us to perform this filtering insights from analysis, we propose a framework called Patterns of Insights. This framework will allow us to figure out if some particular piece of analysis counts as a meaningful insight or not. So there are five basic patterns of insights: unknown result, surprising comparison, surprising extremes, significant outliers, and abnormal distributions. Almost all insights fall into one of these patterns, and knowing them beforehand helps us frame the right question. So let's go through these one by one. The first type of insight is an unknown result. For example, the national animal of Scotland is a unicorn. I did not know this, and it doesn't even make sense because a unicorn is not really an animal, but it's a fact. However, we are more likely to figure out results of the following form, which is revenue of a particular company has increased by X% from the last quarter, or sales have decreased by Y% in this particular financial year. So these are the most common type of insights that we are likely to come up with. We do some computation and we just report the result. But is the result really unknown? That is not obvious when you're doing your analysis, but you can always ask your audience. You can always ask, hey, did you know that X is happening? Now, they may say yes, they may say no, but as you get more and more experience in a given domain, as you do more and more practice, it will become easier to determine whether a particular fact that you have derived from your data is known or unknown. The second is a surprising comparison. We just take any metric and compare it with the corresponding metric of some other cohort. Now that cohort could be your own figures from a different time frame or that of a competitor or anything else that you want to compare against. If it is surprising enough, then it's a surprising comparison. Now, whether the comparison is surprising enough or not is a largely subjective question. But we can deal with this subjectiveness again with some practice and experience. A couple of examples are here. We say that our revenue has doubled since last quarter. So here we have a particular comparison, this time with our own data in a previous data frame. We can also say that sales are only half of that of our competitor. Here we are comparing a particular metric with a different cohort, that cohort being the data set which belongs to a particular competitor, for example. The next pattern of insight is surprising extremes. It basically answers questions like what is the highest, what is the lowest. Pick any metric in your dataset and find its lowest and highest values. If the corresponding details are surprising, then you've found your insight. For example, if you look at LPG coverage in India, you'll find that it's the lowest in some of the poorest states. Now, it's understandable that Andaman and Nicobar Islands might have a low coverage because the islands are far away from the mainland and there may be logistical issues involved in getting gas cylinders all the way to the island. But it's surprising that it's so low in Bihar, Jharkhand, and Orissa, given that the Pradhan Mantri Ujjwala Yojana is targeted towards providing free LPG to women who are below the poverty line. And by the way, this is all from the government's own data. So there's definitely something surprising going on here. To summarize, you can ask any question which contains extremes. What is the highest performing product? Which player scored the most? Which demographic has the least average income? Anything of this sort. And if the result is surprising, then you have found your insight. The next pattern is significant outliers, which is a special case of surprising extremes in the last pattern. Remember that for any metric, extremes will always exist. There will always be a highest and a lowest value. The question is this value so higher or lower than the next highest or lowest value that it counts as an outlier? So let's say if I ask something like who's the tallest person in the room, and somebody stands up, and if we do realize that okay, that tallest person is actually 7 or 8 feet tall, then that's a significant outlier. If that is the case, then that is how you can detect significant outliers. For example, if we say that startups in Bangalore have a 10 times greater chance of getting funded than startups in any other place. Now, obviously, we know that if a startup belongs in a city like Bangalore, which is known for its startup ecosystem, then they would have a high chance of getting funded. but that chance is actually 10 times higher than any other city in the country, then that's a significant outlier. If you remember, this is some analysis we did on the Kaggle data science survey. And we see that out of all the people, especially Indians who are present on Kaggle, the largest job designations are those of data scientists and software engineers, which makes sense. Software engineers and data scientists are quite likely to end up very frequently on Kaggle. But the fact that they are more than twice the size of data analysts available, that is a surprising outlier. We would have expected data analysts to be a little less than data scientists, but not so less, not less than half. Finally, the last pattern of insight is what we call an abnormal distribution. These are mostly just unusual patterns. For example, whenever you are measuring something, you might expect it to follow a specific kind of distribution. But if it has anomalies, then it might be worth investigating. For example, here is a heat map that denotes how many births have taken place in India on average on each day of the year from 2017 to 2007 to 2013. A darker color indicates that more children were born on that day. Now you'd expect birth to be completely random, but we see that there are clearly some significant patterns here. Like almost nobody seems to be born in August. Now there's a reason for this. It's actually because of school admissions. If you are actually born in August, then you're just exactly a month too old to join school at the right time. So what your parents will do is try to squeeze you into the correct academic year by reducing your date of birth by a month or 2 months. So most parents will fake the date of the birth. Also, we see that we have darker patterns on the 5th, the 10th, the 15th, the 20th, the 25th, and the 30th. This is because when people try to come up with fake numbers, they usually come up with round numbers. If you want to make up your child's date of birth, it's much easier to say he was born on the 10th of June or the 15th of July, not something like the 13th of June, right? So this is an example of an abnormal distribution. In this case, we expected randomness, but we found some man-made patterns. It can actually be the other way around as well. You could expect to see patterns, but you end up seeing randomness. That is also an abnormal distribution, essentially. So broadly, these are the 5 patterns of insights which we can use to categorize our analysis. For every piece of analytical fact that we derive, we can ask, does it fall into one of these categories? If it does, then it becomes a good candidate for our final report. But note that when we are doing this sort of analysis and categorization on a given problem, we do not do it on the raw data alone. We do it on the raw data, but we also augment the data set. These augmentations again fall into 2 broad categories. One is the augmentation of data by deriving the columns, and the other is augmentation by summarizing the data itself. This adds columns, whereas this shrinks rows. That might be useful to remember. When we talk of deriving columns, we are essentially adding more columns to the data set by deriving them from existing columns or other data sets as well. For example, let us say that we have the mortality data for COVID-19 for every state in India. Then for each state, we can look up more data from whatever resources are available publicly. For example, if we can get the health budget for each state, we can ask a simple question. For states that are spending more on healthcare, are the COVID fatalities lower? We can also do the same with sanitation data. So essentially, given a column, we can see if we can look up other data from other data sets, which helps us augment our analysis. We can also transform data. If we have something like age, we can bin that or transform that particular column to divide people into buckets like young, middle-aged, and old. We can transform socioeconomic factors like income and education into categorical variables like poor versus rich or educated versus uneducated, and so on. One other way in which we can add more columns is by using machine learning. We can use model predictions to do some sort of clustering on, say, customer data. and try to figure out which of them have similar characteristics. So we can sort of profile our customers using machine learning. Suppose we are working from Amazon or any other e-commerce company, and we want to figure out which products should we offer discounts upon. We can look at the customer reviews and perform, say, something like sentiment analysis on the reviews. The sentiment then becomes a new column. And we can say, we can try focusing our analysis by using the sentiment as the pivotal column. So for those products that have bad reviews, we might want to offer a different rate of discount. Whereas for those products which have good reviews, we might want to offer a different rate of discount. We could also try and see what exactly is causing those bad reviews or good reviews. Is it the vendor? Is it the location? Is it the quality of the product? Whatever it could be. So all of this falls under adding new columns to the data set. The other way of augmentation is summarization. This is usually easier, and we have already covered a bunch of these techniques already. So with all of these methods, we essentially have more columns and more metrics. And then we can reapply the patterns of insights on this augmented data set. That just gives us a lot of new things to work with. But even with all of these checks and balances, it is possible to end up with a set of insights, not all of which we might want to include in our final presentation or our report. Note that these are all insights that are meaningful from the analyst's point of view. They may or may not be useful to the consumer. So we need to take a slightly more client-centric approach. Well, the second advantage of following the patterns of insights is that they allow us to frame questions. In a sense, they allow us to reverse engineer our analysis to some extent. What we would normally do is perform exhaustive analysis on the whole data set and then put all the analysis through a funnel and filter out insights based on these patterns of insights. On the other hand, what we can do is we frame questions upfront using these patterns before doing the analysis. And then the analysis just has to answer these questions. So that restricts our work a bit and it gives it a little more structure. So let's see how to do that. For each pattern, we can create a template for questions, and depending on the data set, we can use that template to sort of fill in the blanks and create the question. So for example, in the case of our first pattern, which is unknown result, this is the template. What is the metric for a given value? The metric can be any metric and the value can be any column in the data set. This sounds very general, simply like asking what is X and what is Y. But then this is the most common pattern of insight, so that's not surprising. And we can use this template to come up with questions. For example, what is the average rainfall in Uganda? Here, the metric is average, the value is rainfall, and Uganda is some filter that you have applied on a country column, for example. Note that you don't have to use these templates as, literally as fill in the blanks kind of exercises. They are more like pointers, they are guidelines. Consider the second question. What is the cheapest place to buy coffee in Mumbai? Here the value is the price of coffee and the metric is minimization, which we have dubbed as cheapest. So the question doesn't look like it came from this particular template, but it's essentially the same thing. And this is good because otherwise all our questions and therefore their answers will look like a robot has written them, which we don't want. The next pattern, which is surprising comparison, is a little more difficult to templatize, but here's an example. Is a metric of a given column greater or less than the same metric of some other column? So basically, I have a metric for a particular column X. Is it greater or less than the same metric for a particular column Y? And if there is a significant enough difference, how much is it? So here are the examples. What percent of urban population has access to personal protective equipment in the USA versus in Italy? You see that these questions have an inherent assumption and then we use them to either verify or challenge these assumptions. In this case, the assumption is that urban populations should have easier access to personal protective equipment. But by framing this question, we are trying to verify this assumption for two of the worst COVID hit countries, US and Italy. If it does turn out that Italy has greater access to per capita or urban population to PPE than the US, that would be a really interesting insight. Here is another example. Are richer countries happier than poorer countries? Here too the assumption is that richer countries should be happier. And if we have the data, we can verify this. By the way, if you actually look at the data, you'll see that this is not really true. The richest countries in the world are clearly not the happiest countries. And then here's the third example. Between demonetization and the COVID-19 lockdown, where did the informal sector of the economy suffer more losses? Now, both demonetization and the lockdown hurt the informal sector pretty hard. And the assumption would be, say, that the lockdown did more damage to the informal sector than demonetization. But there are some studies which show that this is a sampling bias amongst many of us. The thing is that the lockdown has hurt almost everyone, including you and I. And because it has hurt me, it's easier for me to assume that this is the worst thing to happen. But actually, it is quite likely that demonetization was worse. And I am simply not realizing it because I myself was not really hurt that much during demonetization. This time, because of the lockdown, I'm feeling the effect. And that's why I assume that others might be affected too. So that's an example of how you can challenge something like a sampling bias through things like these. The next two patterns, surprising extremes and significant outliers, are very closely related. The latter actually is just a special case of the former, and therefore their templates too are very similar. For surprising extremes, we just ask what is the maximum or minimum of some value. In practice, this is as simple as taking one column and sorting the whole data set by that column. For example, who is the tallest person in the room? You could also augment this question by attaching other attributes to that particular question. For example, what is the gender of the tallest person in the room? Generally, we expect men to be taller than women. Is that also true in this particular case? We can also ask what is the weight of the tallest person? Is the tallest person also the heaviest person? That question makes sense because you would expect weight to increase as height increases. This pattern again allows you to verify or reject a particular belief. Note that clients can have very strong beliefs about their businesses. And if you can challenge their beliefs with analytical evidence, they will absolutely love you for it. Of course, it's also possible to find clients who are not ready to change their beliefs even in the face of evidence, but that cannot be helped. It's well known that emotions matter more than facts. Anyway, back to the point. The next pattern, which is significant outliers, is just a special case of surprising extremes. You see that there will always be extremes. There will always be some minimum or some maximum value for a particular metric, unless it is a constant, in which case you should not have it in your data at all. But if the highest or lowest value of every any given metric is so ridiculously high or low that it completely dwarfs the next highest or lowest value, then it's an outlier. So the template here is like how much greater or less is the highest or lowest value than the successor. I know, for example, that say Mumbai has the most flood related deaths. That's obvious because Mumbai is notorious for being a low lying area and not being able to cope with the monsoons very well. But if somebody told me that the number of flood related deaths in Mumbai is 5 times as large as something in Kolkata, that would be a significant outlier. Finally, the last pattern, abnormal distributions. Here again, we start with some expectation and we frame the question in a way that verifies that expectation. For example, what is the expected distribution of a value and does the data match that distribution? Here is a specific example of this particular kind of question. In Sholay, is Amitabh Bachchan's coin toss really random? Now, this question might make sense only to those of you who have seen the movie. And by the way, if you haven't seen Sholay, this is a good excuse to go and watch it. Consider it your homework if that helps. Basically, the point is that if Dharmendra's character in Sholay was a data analyst, he would have very quickly realized that something is wrong. The coin toss follows an abnormal distribution. Anybody would have thought that how is it 50-50 if one person always wins? Second example, which we have already seen, is that dates of birth across the whole year are not uniformly distributed, which they should be. And finally, we hear statements like these so many times. 9 out of 10 startups fail. We don't know where this figure of 9 out of 10 comes from, but if we had data, we could verify it. So that broadly covers how we can use patterns of insights and how we can use them to frame questions and perform analysis along those questions. Before we conclude this section, I want to introduce you to one more framework which allows us to filter insights even further. This framework is what we call the BUS framework. It says that insights have to be big, useful, and surprising. And this is what it means. Suppose you tell a client that according to your analysis, if they change a certain business practice, their revenue will grow by 1%. Now the client will say that, boss, anyway the fluctuation in my revenue is plus minus 10%. This 1% means nothing at all. And then on top of that, you are asking me to change the way I run my business, which is likely going to cost me more than the 1% of my revenue. So your insight is just not big enough. To begin with, the analysis has to be statistically very robust. The probability of your analysis being correct has to be very high. But if the impact of that analysis is low, then it's just not big enough. Let's say that we make the following statement to our client. We are 99% sure that if you do X, your revenue will increase by 10%. But we are only 70% sure that if you do Y, then your revenue will increase by 30%. In this scenario, the client is likely to adopt the second recommendation because the first is just not big enough. And even if you're only 70% confident about the second scenario, that is still might be a risk worth taking. Now, the second question to ask is the insight useful or is it actionable? Suppose a venture capitalist were to hire you and they ask you to study startups and small businesses and their likelihood to succeed so that you can give some advice on where they should invest their money. Now, you do your analysis and you discover the biggest driver of a startup success is the country of that startup. The highest impact on the success of a startup is that of the country because presumably ease of doing business matters more than any other factor. And ease of doing business is directly related to the economy, to the laws, and a lot of establishment related things in general. So then you go to your client and say that they should invest in startups which are in New Zealand or Singapore because those countries have the highest ease of business rankings. Your client might say that, look, these markets are already captured by other investors. That is not my market at all. What can you tell me about my market? So, this is an example of something which is not useful, something which is not actionable. Another example of this is one analysis that we were doing on cricket scores. So, apparently, if you try to quantify the performance of a particular batsman or a particular bowler, it seems like the country or the team that they play for has the highest impact in how well they perform. There are certain countries whose players overall will perform better: India, Pakistan, South Africa, and so on. Not surprising. But then, if you were actually to turn this into a data analysis problem and say that, okay, what do I need to do in order to improve my performance? You might easily be able to say that, hey, according to my analysis, since country is the biggest driver in performance of cricket scores, why don't you go and play for a different country? Now that's again an example of an insight that is not actionable. I can't just walk up to some other a better team and ask them to let me play for them. Finally, don't tell your audience something that they already know. Tell them something that is not obvious. So if an insight meets all these three criteria, then you can use it. The problem with the big, useful, surprising framework, though, is that it is very subjective. After all, how will you know if the client knows something or not? How will you know if something that seems big to you is also big for the client? Unfortunately, this kind of acumen comes only with experience and practice. But that doesn't mean that we cannot use this framework. We can always talk to our clients, we can interview any other stakeholders, interview them about what sort of things count as big, useful, or surprising. We can always do multiple rounds before we make the final presentation. And that's actually a good thing because that way we can, that shows engagement also to some extent. In any case, we can always exploit the inherent subjectivity of the problem. The fact that these are subjective measures can actually turn into an advantage for us. For example, we can define a simple scale of low, medium, and high. And for each insight, we rank it as low, medium, and high across all of the bus metrics. And then we can create our own filtering rule. Like if any insight is medium or high on all three bus factors, then we will include it in the final report. So here are a few examples. Let's say we figure out that project managers get paid 5 times as much as data analysts. Is this big? Absolutely. 5 times is a big magnification. Is it useful? Well, that depends. Useful to whom? It is somewhat useful to data analysts because they can use this insight to try and get either promoted to a project manager or go and get an MBA. Is it useful to employers or recruiters? Definitely. Because if this is the market standard, then they know roughly how much they should pay for which particular designation or which particular role. Finally, is it surprising? Not really. People may not know the 5x multiplication factor very precisely, but they know that this is generally true. That is, managers do get paid much more than data analysts do. They may not know how much, but they know that that order relationship exists. The second example here is that business analysts get paid twice as much as data analysts. Now, this has a high rating across all columns. It's definitely a big figure. It's useful because it will prompt data analysts to label themselves as analysts, and it is surprising too, since you would assume that business analysts and data analysts do almost the same kind of work. So broadly, the idea is that you can rank each insight by how it performs within the bus framework and use this as a checklist for what to include in the final analysis. Feel free to pause the video here and take a look through the rest of the examples as well. To summarize this module, we have talked in detail about how analysis alone doesn't generate insights. In fact, analysis is a superset of insights. Analysis has to be filtered into insights. And in order to do that, we covered two methods. The first one we call patterns of insights, and we talked about the 5 patterns of insights and how they can be used to frame questions, which in turn can drive our analysis in the first place. Finally, we learned how we can rank each insight as a big, useful, or surprising, and how to use these rankings as a second set of filters against our insights. In our forthcoming interactive sessions, we are going to go through many examples of how we can actually apply all of these things in practice to the point that they become habits. So till then, all the best and see you soon.